Okay, you guys, sorry, camera's a little shaky. So we are talking about combining like terms today. So last time in class, we talked about what is a term, right? We talked about terms and coefficients and constants and variables, all that good stuff. Okay, so let's just remind ourselves, what is a term? Okay, so let's go ahead and just define it over here. Okay, so a term is, we'll just say a piece of a mathematical sentence, right? It's not always an equation, not always an expression. Separated by addition and subtraction signs. Okay? Beautiful. Okay, so a term, a piece of a mathematical sentence separated by addition and subtraction signs. So let's answer number one. What makes a term a like term? What makes it so you can actually combine them? Okay, so the biggest rule is you can only combine like terms. Okay, in fact, that's a huge rule in math. Only combine terms that are alike. Okay, so what makes a term a like term? What makes it so they are alike? This is if a term has the same variable and to the same power, it's a like term, meaning you can combine it. Okay, so same variable, same power. That's what makes a term a like term. Okay, so let's look at our examples. So all of today we're going to be focusing on combining these like terms. We're simplifying these expressions, right? It's asking us to simplify the expression, and how we do that is we combine like terms. Okay, so let's look at our two terms here, right? We have two terms. Okay, well, are these terms like terms? Meaning, do they have the same variable and same power? Okay, so I see in my first term, this one has a v to the first power, right? And this second term also has a v to the first power. So are these terms like terms? Yes, they are. Okay, so that means we can combine them. So let's pretend just for a second that we don't have v's anymore. Let's say that these v's represent violins, right? I just thought of that off the top of my head. Okay, so I have 10 violins, or 10v, and I'm subtracting 2 violins, or 2v. Okay, how many v's, or violins, do I have? 10 minus 2. Okay, so 10 minus 2 is going to give me 8. Nice job. Okay, so the first step is, are they like terms? Okay, we identified that they are. The second step was to look at the coefficients, meaning look at the numbers in front. Okay, 10 minus 2, that's all you have to look at. Look at coefficients. Okay, our last step, because our answer is not 8. 8 what? Okay, our last step, add the variable. So just put the variable back on there. Okay, so what was it? 8v, or 8 violins. Ew, that's an ugly box. Okay, and that is our simplified expression. Okay, so we can combine 10v minus 2v to give us 8v. Okay, so let's look at number 3. So I have two terms, 5b and negative 2b. Are they like terms? Okay, so let's answer these questions. Are they like terms? Okay, this one has a b to the first power. This one also has a b to the first power. That means yes, they are like terms. Okay, so now let's just look at the coefficients. So let's do baseballs for b. So I have 5 baseballs, subtract 2 baseballs. Okay, how many baseballs do I have? 5 minus 2 is going to give me 3. Okay, just put the variable back on there. And that is our simplified expression. Perfect. Okay, let's look at number 4. Okay, so in number 4, I have 1, 2, 3, 4 terms. Okay, what terms are alike here? Meaning same variable to the same power. Okay, so I see a 6b right here. And then the only other like term is this negative 5b, right? Same variable, same variable. They're both to the power of 1. So we can combine those. Okay, so now look at the signs in front. So I have 6. In fact, we can even rewrite it. 6b, I'm just going to put them together so they are nice and together. 6b minus 5b. How many b's do I have? 6b minus 5b. I just have 1b. Okay, and we don't have to put that 1. Okay, so that's not our simplified answer because what else do we have? Remember, what is that word for numbers that are all by themselves? It starts with a C. These guys. Those are constants, right? So those are just numbers that are all by themselves, constants. Okay, well now we can put those together. What's 1 plus 8? Okay, we get 9. Perfect. And so that means our final answer is 9. Okay, we're not putting these together. We had a 9 plus 1b. Okay, these are not like terms, right? The 9 doesn't have a b. This one has a b. So that is simplified. That's our answer, right? Our simplified expression. Okay, number 5. So let's identify our like terms here. So I see one term with a variable, right? So I see this 10m with a variable. Okay, do you see any other terms with an m? Nope. So we know that that 10m is just going to stay 10m. Okay, what about this 7 minus 9? Okay, our constants right there. Okay, what is 7 minus 9? What is that going to give me? Negative 2. Okay, 7 minus 9, we're taking away more than we have, negative 2. So now our simplified answer, let's put them together. Okay, 10m minus 2. Okay, they're not like terms because one has a variable and one does not. So that is our simplified answer. Okay, let's look at number 6. Okay, we have two terms here. Are they like terms? So I see this 7a has a variable and then just 1a right here. Are these guys like terms? Yes, they are, right? Because this is technically 1a. So what is 7a? So let me rewrite that. 7a, or think like 7 apples minus 1a, or 1 apple. How many a's or apples do I have? 7 minus 1? 6a. Right? Is there anything else to combine? Nope. So that is our simplified expression. Okay, number 7. Where are my like terms here? I see one variable, which is n, and then I just see two constants, 7 minus 9. Okay, so I can't combine the n with anything. There's no other n's. But I can combine this 7 minus 9. Okay, so let's write, we know that our n is just going to stay n, 1n. Okay, but then what is 7 minus 9? Hint, we already did it right here. Okay, negative 2 again. Okay, so our answer to this guy, we have 1n and then minus 2. Great job. Okay, let's look at number 8. Okay, one thing that we now see in number 8 that we didn't see in any of our previous expressions are these parentheses. Okay, when you see parentheses, parentheses with a number right in front of it. So notice it is right next to that parentheses. Parentheses with number right next to it. Okay, that means it's being multiplied. Okay, another word we use for this in math is distribute. And what that means is we are distributing, whoops, sorry, can't really see all of that. Okay, we are distributing, or think giving, right? That's what distribute means. We are giving that 10 to both terms inside. Okay, and how we give that is we multiply. Okay, so let's multiply the 10 to both terms inside. So first one is 10 times n. What is 10 times n? Okay, that is just 10n. Okay, what's 10 times 8? It's going to give me 80. Okay, so let's rewrite this and see if we can combine anything. 10n plus 80. And whoops, I totally just got ahead of myself. Okay, that is our simplified expression because 10n and 80 are not like terms, right? The 10 has the variable, the 80 does not. Okay, so we distributed that 10, which, excuse me, means we are multiplying that 10 to both terms inside. Okay, let's do number 9. So we see some parentheses with a number right in front. This time it's a negative 10. Okay, we're going to do the same thing though. It's being distributed or multiplied to both things inside. So let's list it out. First one, we have negative 10 times 1. Okay, what does that give me? Anything times 1 is just itself, so negative 10. Okay, and then we have a negative 10 times a positive 3x. Okay, a negative times a positive is always going to give me a negative. Okay, 10 times 3 is going to give me that 30. And then since there was 1x, we have to include the 1x. Okay, now let's rewrite it. Let's just put them together. So we had a negative 10 minus 30x. Okay, are these guys like terms? Can we combine them? No, we cannot. Okay, so that is our simplified expression. Okay, last example. So again, we see the parentheses, which means we're distributing. So the number right in front is what's going to distribute or be given or multiplied inside. Okay, so we have a negative 3 times 9 first. What's that going to give me? Negative 27. Okay, then we have a negative 3 times a positive 10k. Again, negative times a positive is going to give me a negative. 3 times 10, 30. There was 1k being multiplied, so we put it on the end. Okay, so now we can just rewrite it. Negative 27 minus 30k. Okay, and now we ask ourselves, are these guys like terms? Can I combine it or simplify it anymore? No, they are not. One has a variable, right? The 30 has the variable, the k. The other one does not, so it is as simplified as it is going to be. Okay, shorter notes today. Gives you guys plenty of time to work on your assignment, get it all done. Okay, make sure your notes are all filled out. They will be linked on Canvas, and make sure you do your assignment. Awesome. Bye.